I'm Anil Kumar. Welcome to my video on kinematics, and thanks to my subscriber, Arun. We are looking into the calculus part of antiderivatives now. The question here is, a particle moves along the x-axis. It passes the origin O with a velocity of 8 meters per second and its acceleration a in meters per second square t seconds after passing O is given by a equals to 3 minus t. You need to calculate all these things, which include velocity of the particle when t equals to 2, the maximum velocity of the particle, the displacement of the particle from O when it is at rest, and d, the average speed in the first 12 seconds. Okay, for some of my students, this concept of antiderivative is relatively new, so I'd like to give you a short note on that. Till now in calculus, what we have learned is that we start with displacement, right, s of t, and then we say that the velocity function, v of t, is derivative of displacement, right? It is ds of dt, right? So it is the derivative, and acceleration is derivative of velocity. So we say dv dt. So all are functions of time, so I'm putting this time in brackets. So this is what we had been doing so far. Now what we are given here is the acceleration. Now since acceleration is given and we need to find the velocity, then what should we do? We'll do reverse of what we had been doing, right? So we'll now go in the reverse order. So this order was derivative, right? So this was derivative. Now we are going in the reverse order and we call this antiderivatives. We'll soon learn how we could use integration also, which is the same thing in a very formalized manner. So that is what we are going to do. Is it okay? So for antiderivative, let me write down few basic rules. So when we go in the reverse order, we are doing all things in the reverse way. So if we have a function, let us say we have a function, let's say 0. Now you know derivative of what is 0? Derivative of constant is 0, right? So the antiderivative will be a constant. So we take 1 as our value, correct? So we take just 1. It could be any constant. We keep it simple. I'll explain you as we go along why just 1, okay? But if the function is 1 or a constant, then we keep this value as x, right? So because derivative of x is 1, okay? Derivative of x is 1. So if the function is, let's say, a constant k, then it will be kx, fine. But if the function is some power of x, x to the power of n, then we apply the power rule in the reverse way. So we get this derivative as x to the power of n plus 1 divided by n plus 1. So now you can see, if you work for the derivative of this, you get x to the power of n. So that is how it works. Now with that brief discussion, let's begin and answer our questions. Now here we are given two things. One is that this particle is moving along the x-axis, so we are only talking about motion along a straight line. So that is the straight line which we'll consider. And when we do so, we are considering only the displacement, right? So we are always looking into displacement from a fixed point. This fixed point is given to us as origin. So a particle moves along x-axis, it passes through origin O with velocity 8 meters per second. Now that is called the initial condition. So we have initial conditions here. So we'll see at O, we'll say time starts now. So we say t equals to 0, velocity, initial velocity, or velocity at t equals to 0 is 8 meters per second. Correct. So that is given to us. And then at this time, acceleration is 3 minus t. So we are given at this time that acceleration A is equal to 3 minus t. Now, we need to find velocity of particle when t equals to 2. And we have to find velocity when t equals to 2. This is what we have to find. So that is the question for us. Perfect. So what we do here is we do the reverse operation. We find the antiderivative, since we know that velocity dv dt is a, right? So we know that dv dt, derivative of velocity, is a. Since we want to find what velocity is, we will do antiderivative, right? So at this stage, we'll do antiderivative. So a is equal to 3 minus t. So from here, we get velocity should be equal to antiderivative of 3, which is a constant, right, will be 3t, right, since we are working with time as the independent variable. So we get 3t minus, for t, power is 1, so we could write this as t squared over 2. Now we add a constant c here. Now this constant c is very important because as we have seen here, for any constant, derivative will be 0, right? So now the idea here is to find c from the initial condition. So we are now going to use this initial condition to find c. We know when t is 0, that is to say when these things are 0, velocity is 8. So substituting this condition, we get 8 equals to 3 times 0 minus 0 plus c, and that gives you the value of c as equal to 8. You get the idea, correct? So from here, we get the function velocity, which is equals to 3t minus t squared over 2 plus 8. Perfect. Since we have this expression of velocity, we can always find the value at t equals to 2. So we'll just highlight this particular equation, which is going to be used later for all other parameters. And we will now calculate what is velocity at t equals to 2. So let me do it here. So velocity at 2 will be, I'll substitute 2 here. So we get 3 times 2 minus 2 squared over 2, which is 4 over 2 plus 8, right? Plus 8. So that gives you 6 minus 2 plus 8, which is 12, and the units are meters per second. Is it okay? So we get the answer for the first part, and we know that velocity at 2 is equal to 12 meters per second. Perfect. So I hope this part is absolutely clear. Now let's move on, and we'll find the maximum velocity of the particle. Now let us see how to find the maximum velocity of the particle. We are given that a, the acceleration, is equals to 3 minus t, right? Now we also derived that the velocity of the particle, v, could be written as 3 times t minus t squared over 2, and the initial condition 8 meters per second, that means plus 8, right? So that is how you directly can get the velocity by doing antiderivative of a, right? Now maximum means what? Maximum means that dv dt should be equal to 0. So that is what is called the critical number, right? We need to find the critical number and then analyze that number. Now dv dt is basically a, so we already have that expression, which is a equals to 3 minus t, correct? So we can directly analyze a equals to 3 minus t. So from here, we can say, so we'll now use this equation. We are already given this. So when we say dv dt equals to 0, let me rewrite. So when we say dv dt, which is equal to a, is equal to 0, it really implies that 3 minus t equals to 0. So that gives you t equals to 3. So t equals to 3, is our critical number, right? So the critical number is t equals to 3. So if I substitute, so let's analyze this part first, and then we'll find the maximum velocity of the particle, correct? So if I analyze dv dt over the interval, so let's say here, and this is where t equals to 3. So let's take a test point on either side. Let's say we take 2 and 4, right, on either side, and we are trying to analyze the function 3 minus t. Correct? So if you analyze 3 minus t, if I substitute 2 here, I get a positive value, and if I substitute 4, I get a negative value. So that clearly means we have maximum at t equals to 3. Correct? So that is how you can reason it out. Sometimes it is not required, but since I have many viewers for whom this could be a new concept, I am actually going slow on this. Okay, so t equals to 3 gives you maximum velocity, so we can now calculate it. So maximum velocity will be at t equals to 3, right? So at t equals to 3. So I'm going to substitute this value in our expression, which is 3t. So we'll just write 3 here, minus 3 square over 2 plus 8. Correct? So that gives you 9 minus, this is 4.5, let's take decimals, plus 8. Correct? So 9 plus 8 is 17, and this will give you 12.5, units being meters per second, right? So that becomes the maximum velocity for this particular particle, right? So I hope this part is absolutely clear. Now let's talk about displacement, which is antiderivative of velocity. So in part C, we need to find the displacement of the particle from O when it is at rest. Now when I say when it is at rest, it means what? So it means that we need to find when is the velocity 0. So that is first part, right? So when is velocity equals to 0? So we need to find this time, correct? And displacement means we need to find an expression for displacement also. Okay, so we already have the expression for velocity. We know velocity is equals to 3t. We got it directly from here, minus t squared over 2 plus 8 seconds, which is the original value. Now, to equate this to 0, I will write 0 here and then find what t is. So that is it. So let's rearrange this. Let me do it in 2 steps. Okay, so I'll write t squared over 2, and then we'll write plus 3t plus 8. I'm going to take minus half common. In that case, I get t squared, multiplying this by 2, negative sign, 6t and minus 16, right? So that could be factored, correct? 8 and 2 will give you 16, 1 negative 8. So we get t minus 8 times t plus 2. So we get this in factored form. So from here, you know that t should be equal to 8. Since minus 2 is not valid, we know that t is greater than or equal to 0. Correct? So we know that the particle is at rest. We can say particle is at rest when t equals to 8 seconds. Perfect. Now the idea is to find the displacement, since we want to find displacement of the particle from O, right? So we have to do antiderivative of velocity function. Is it okay? Since we know that ds dt, displacement is s, is equals to velocity, which is equal to 3t minus t squared over 2 plus 8. So what is displacement? So from here, displacement will be antiderivative of velocity. We are moving backwards now, correct? Applying the rules which we just learned, antiderivative of t will be t squared over 2. So you'll get 3 times t squared over 2 minus, add 1 to the exponent. It is 3. So already half is there. So this is 3. So 3 cubed over 3, right? Plus 8, so it becomes 8t. So that becomes the displacement, and the initial condition here, we always write c, but since we know that the particle moves along x-axis, it passes through origin O. So we know at t equals to 0, s equals to 0, right? Therefore, this c equals to 0, right? Because of the initial condition, right? So we know at t equals to 0, particle passes through origin, this part, and so c is equal to 0. Is that okay? So we'll stick with this definition of displacement. We need to find how far, or the displacement of the particle from O when it is at rest. It is at rest when t equals to 8. So let's write t equals to 8 for this expression. So s of 8 is equals to what? So get 3 times 8 square over 2, right, minus 8 cube over 6 plus 8 times 8. That is the answer, correct? So let's use the calculator and figure it out. So we have 8 square times 3 divided by 2 minus 8 cube divided by 6 plus 8 square, which is equal to, we'll write decimal equivalent of this, 74.66. And meters is the unit. So that becomes the displacement from the origin for the given particle, right? So what we're trying to say here is that the particle position at is somewhere here, which is 74.66 when t is equal to 8 seconds. That is what we are saying, right? S of t is along this x-axis from origin. So now let's move on and then do the next part, which is to find the average speed during first 12 seconds. Now we'll find the average speed during the first 12 seconds. Now in the previous part, while calculating the displacement, we got an expression for displacement, right? So we found that the displacement s at any time t is given by 3 times t square over 2 minus t cube over 6 plus 8t, right? And we also found that at t equals to 8, velocity equals to 0, right? So that is a very critical information, and that gives you a turning point, right? And at this point, we also calculated that s at t equals to 8 is equal to 74.66. Correct? So this is what we did in part C. So let's continue from here. Now the information which I am sharing with you in this form could be seen on the movement of the particle as from 0, t equals to 0, the particle moves 74.66 meters away. So that is the position when t equals to 8. We want to find in first 12 seconds. So let us also calculate the displacement of the particle when t equals to 12. So if I substitute 12 here, I get 3 over 2, 12 square, minus, we have 12 cube over 6 plus 8 times 12. So let's calculate this value now. So we have 12 square times 3 divided by 2 minus 12 cube divided by 6 plus 8 times 12. That gives you 24. So this value is 24. So displacement at t equals to 12 is 24 from the origin. All this is from origin. Now we know this position here is at 74.66. Now 24 is much lesser, right? So that means the particle has returned, and it makes sense since we have velocity 0 here, so it could be treated as a turning point. So it moves back from here, and the displacement is, that is to say, distance from origin is 24. Correct? So that means from t, when t is from 0 to 8 seconds, at that time distance is 74.66. Now when t is from 8 to 12. In that case, what is the distance? So we need to find this distance. So that distance is the absolute value, correct? So it is the absolute value of the difference. So it is absolute value of, we'll do 74.66 take away 24. Does it make sense to you? Right? So that is what it is. So we have to add this. That becomes the distance, correct? So let's do it, and then we'll add both these distances. So we have 74.66 take away 24, which is in decimal 50.66, correct? Okay, 50.66. So the total distance covered is how much? We have to add both these distances. So we get 74.66 plus 50.66, correct? So we'll add this to 74.66. So adding them, we get in decimals 125.32. Perfect. So that is how you're calculating the total distance. We need to find average speed. We know what is the total time. Total time is 12 seconds, correct? So now it is easy to find average speed. We can say that average speed is 125, the total distance over this ratio. This is what we are trying to find, correct? So it is 125.32 divided by 12. So we'll divide this by 12, which is 125.32 divided by 12 is equal to, in decimals, it could be written as 10.44. Let's say 10.4 meters per second. So that is how you could find average speed of the particle. So I hope you understand the whole concept. This is an excellent example. Just one example will give you all insight to similar questions. So we started with acceleration with initial condition of velocity of 8 meters per second when a particle passes through origin. From there we found the expression for velocity by using antiderivatives, and then we analyzed velocity. It was 0 for t equals to 8, so that is the turning point as shown here, and we knew how to find displacement by antiderivative of velocity. We got cubic equation there, and substituting the values we could calculate all the things required. I hope it makes sense. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.